Namaste everyone. Welcome to 7th lecture of differentiation. This is Rajesh. In this lecture we are going to see second order derivative and solve problems of exercise 3.6. Now let us understand what is first order derivative first. So if y is equals to fx and it is the differentiable function of x, then dy upon dx is equals to f dash x is called first order derivative of y with respect to x. It is also denoted as y dash or y1. So here dy upon dx or f dash x or y dash or y1, they are all nothing but various forms of writing derivative of fx with respect to x. This is our first order derivative. Now let us understand what is second order derivative. So if dy upon dx is equals to f dash x is first order derivative of y and is a differentiable function of x, then we can differentiate this dy upon dx again with respect to x and denote this as d square y upon dx square, or we can also denote this as by f double dash x. This is called second order derivative of y with respect to x. It is also denoted by y double dash or y2. So d square y upon dx square or f double dash x or y double dash or y2, they are nothing but they are second order derivative of y with respect to x. Now let us solve few problems related with second order derivative. So here we have to find d square y upon dx square, that is second order derivative. Function given is y is equals to root x. So first I will differentiate this y with respect to x. I will get dy upon dx as 1 upon 2 root x, that is 1 upon 2 x power minus 1 by 2. I will differentiate this function again with respect to x and I will get d square y upon dx square is equals to this 1 by 2 will remain as it is, and derivative of x power minus 1 by 2 is minus 1 by 2 into x power minus 1 by 2 minus 1, that is x power minus 3 by 2. So on simplification I will say that d square y upon dx square is equals to minus 1 upon 4. In denominator I have x into root x. This x power 3 by 2 is x into root x. Second question is y is equals to x power 5. I will leave this problem to solve by yourself. You differentiate this first with respect to x and then again whatever answer you get, again differentiate that with respect to x. Third question is y is equals to x power minus 7. So here first we differentiate this function with respect to x. We get dy upon dx as minus 7 into x power minus 8. We again differentiate this function with respect to x and we get d square y upon dx square as minus 7 into minus 8 into x power minus 9. Therefore d square y upon dx square is 7 8 is 56 and this x power minus 9 I will write as divided by x power 9. Second question, y is equals to e power x. Now here y is equals to e power x. I differentiate this function with respect to x. Derivative of e power x is e power x only. So here I can replace this e power x by y also. Now again e power x I can differentiate with respect to x. So d square y upon dx square, that gives me e power x. So d square y upon dx square is equals to e power x. I can also say that d square y upon dx square is equals to y. Now second question is y is equals to e power 2x plus 1. I will differentiate this function with respect to x. This is a composite function. So dy upon dx is e power 2x plus 1 into derivative of 2x plus 1, that gives me 2 into e power 2x plus 1. I will differentiate this function again with respect to x. So I get 2 into derivative of e power 2x plus 1 again gives me value as 2 into e power 2x plus 1, that is 2 to the 4, 4 into e power 2x plus 1. Third question is y is equals to e power log x. Now here y is equals to e power log x. I will differentiate this with respect to x. This is again composite function, so I get dy upon dx as e power log x into d by dx of log x. Derivative of log x is 1 upon x, so it is e power log x upon x. Now I will differentiate this function again with respect to x, so I will use u upon v method. So d square y upon dx square will give me x into derivative of e power log x minus e power log x into derivative of x whole divided by x square. Simplification of numerator will give me x into e power log x upon x minus e power log x into 1 whole divided by x square. Now this x will cancel, and in numerator I have e power log x minus e power log x, that gives me answer as 0. So d square y upon dx square is 0. Now I can solve this problem in one more method. There are many methods in which you can solve derivative. So let us try one more method. Y is equals to e power log x. So here first I take log on both the sides. That gives me log y is equals to log x. This log I can cancel and I get y is equals to x. So differentiating this with respect to x, we will get dy upon dx is equals to 1. Now again when we differentiate this dy upon dx with respect to x, we get d square y upon dx square is equals to 0. So let us revise what we studied in derivatives in our 12th standard. First, we have seen derivative of composite functions, right? You remember what is composite function? Yes, when I express y in terms of say some function u, where u is based on some function x, then I will say that y is a composite function of x. For example, y is equals to 4x plus 7 whole power 10. So this is considered as a composite function. So we have seen how to differentiate composite function. Second, we find derivatives of inverse function. Derivatives of inverse function, that is, instead of finding dy upon dx, we have find out dx upon dy. Now we first understand what is inverse function, and we said that when inverse of a function exists, that is, if a function y is given in terms of x, and if its inverse exists, that means we can express x in terms of y, then in that case how we can find dx upon dy? So first we differentiate y with respect to x, that is, we first find dy upon dx, and then with the definition of inverse we say that dx upon dy is equals to 1 upon dy upon dx. This is derivative of inverse function. Thirdly, we have seen the derivative of logarithmic functions. So where we use this kind of problems whenever the problems are like y is equals to, we have many multiplication terms like log x into x power 10 divided by x power 15 divided by 4x plus 10, something like that. Means when we have lot of multiplication division is involved, or when we have base and power both are in terms of variable, then in all those kind of problems it is easy to use logarithms on both the sides. We have seen some rules of logarithms, we have seen some formulas of logarithm, and using those logarithms our problem become little easy. So we first take logarithm on both the sides and then differentiate with respect to x or whatever variable is given. Then we have seen implicit function. Now what is implicit function? So if it is difficult to express y in terms of x or x in terms of y when they are all together, then in that case it is considered as implicit function. And how we differentiate here? So we have differentiate with respect to the variable whatever is given, and finally we collect all the dy upon dx terms on left hand side and other terms on right hand side, and like that we have find out derivative of implicit function. Next we have seen parametric function. So when x can be expressed in terms of some parameter t and y also can be expressed in parameter t, and both x and y are differentiable with respect to parameter t, then in that case we can find dy upon dx as dy upon dt whole divided by dx upon dt. So this is parametric function and derivative of parametric function. And lastly, we have seen the derivative of second order. Now derivative of second order means first we differentiate with respect to x, we find dy upon dx. This is first order derivative. We differentiate this first order derivative again with respect to x, and what we get is called second order derivative, right? Similarly, we can have third order derivative, fourth order derivative, and so on. Thank you.